So in the next few years, in the early 2020s, NASA will be sending a spacecraft named Clipper to the Jupiter system. One of the places that Clipper will visit is a small icy moon named Europa. This moon is the closest we've come so far to identifying a place with some of the ingredients needed for a habitable environment for life on Earth. Clipper will be going to Europa to look for these ingredients of life, as well as look for potential landing sites for subsequent missions. Thus far, NASA engineers and scientists have already worked together for at least a decade on the mission. However, they are spread across the four corners of the United States. And in order for them to call a mission a success, they need to work in sync, and despite being scattered across the country. Complex information such as spacecraft orientation, science information, and orbital trajectories need to be shared regularly amongst team members. So with this in mind, we asked ourselves this question: how might we help remotely located NASA engineers and scientists collaborate together in the upcoming Clipper mission? To answer this question, we interviewed 17 scientists and engineers, as well as domain experts, and discovered 3 core collaboration needs, was discussing highly technical information remotely. Eugene will tell you more about these needs in detail.
Thank you. The first of these needs is for time-sensitive tools, which takes into account the high-stake nature of spacecraft missions, especially the Europa Clipper mission. As a system engineer put it, once you're in the Europa environment, you're working against the clock. Because the Jovian system is a highly irradiated environment that would damage the health of the spacecraft every time it traverses Europa. In that, decisions need to be made within a short window of time on the ground, and tools need to accommodate that quick turnaround and data collection period. Secondly, there's a need for new yet proven technology. Paradoxically, cutting-edge technology is desired in every space mission, yet they're so niche, so there are no proven track records elsewhere to refer to. As a tool developer mentioned, if we're making decisions on where the spacecraft should go, we should use the best technology possible. However, in order to minimize the chances of mission failure, scientists and engineers prefer to be conservative and use tools that have a proven history of success. As a system engineer put it, there's decades of experience that leads NASA to doing things a certain way. Lastly, there's a need for sharing 3D information. Much of the information collected by NASA is complex yet inherently 3D information like trajectories and orbital and celestial bodies. In that, there has been a long-standing need and pain point to share that information intuitively among mission personnel. An engineer at JPL mentioned that there's only a handful of people who can visualize the orbital trajectory, and outside the navigation team, it's very hard to get the point across. We believe that effective conveyance of 3D information can introduce more productive forms of collaboration. With all these needs in mind, let's take a look at SpaceTalk in action.
For decades, scientists and engineers at NASA have dedicated their lives to the Europa Clipper mission to answer the question, is there life beyond Earth? The tools and methods they use to collaborate with each other can directly affect these efforts. SpaceTalk uses the power of existing smartphones to create a virtual reality space simulation to empower engineers and scientists to collaborate together. In SpaceTalk, NASA mission personnel can become the spacecraft and see the coverage of their science instruments. Collaborators can also switch between different orbits and view the past, present, and future states of the spacecraft. SpaceTalk also enables collaborators to easily view when science is being collected in the mission. It also allows you to capture important moments of the talk so you can share with other mission personnel. SpaceTalk, bringing mission teams together in space.
SpaceTalk is a mobile virtual reality application that allows NASA engineers, scientists, and mission personnel to remotely collaborate in a virtual simulation of the mission. Think Skype or FaceTime, but in virtual reality. Collaborators can discuss complex mission information as if they're having a discussion right next to this orbiter in space. Designed with mission personnel's needs in mind, SpaceTalk is, for one, time sensitive. NASA personnel can quickly and easily request a VR call with other collaborators with a specific orbit. Once accepted, they place their smartphone into the VR headset to be transported into an immersive simulation of the mission. As opposed to traditional laptops, desktops, or VR headsets that are plugged into computers, we think the mobility of smartphones is ideal to accommodate the time-sensitive nature of the current mission. Secondly, SpaceTalk falls into the sweet spot of being a new yet proven technology. It leverages the familiarity of existing smartphones while meeting NASA's need for new tools to better understand mission information. Mobile virtual reality is highly accessible and adaptable, with a headset being a fraction of the cost of the current VR technology and only needs a user's smartphone to access the virtual environment. Lastly, SpaceTalk allows mission personnel to share information in its most natural ways. By leveraging NASA's already existing practice of inputting all mission-related information in their existing databases and application, SpaceTalk displays this information in an entirely new way. One with 3D perspective to show relationships between celestial bodies, mission information, and information layers. Here, scientists and engineers can see the states of their instruments shown along an orbital path, a type of information that is inherently 3D. Additionally, SpaceTalk integrates mission information to optimize collaboration. The application features 5 different information zones in which collaborators can view distinct information at optimal distances. These 5 information zones are instrument coverage, spacecraft orientation, science instrument schedule, spacecraft communications, and then lastly, the Jovian system. In this particular information zone, we see a collaborator seeing through the eyes of the orbiter to understand the coverage of their science instrument, just if they were looking through the lens of the camera. And I'll pass it to Brian to wrap things up.
Thank you, Terry. So before we end here today, let's take a journey back to July of 1969. This is when NASA was at the peak of its Apollo program. It was also a time when the whole world watched in awe as Neil Armstrong first stepped foot on the moon. Yet, in order to achieve what many considered to be impossible, for the first time ever, computer systems had to be used throughout the entire duration of spaceflight. And this was to help the hundreds of men and women on the ground at Mission Control collaborate together to monitor the Saturn V rocket and its brave crew of astronauts. So today, exciting new missions like Europa Clipper are on the horizon and have the potential to answer mankind's biggest questions. What if an entirely new generation of scientists and engineers leverage the full capabilities of cutting-edge immersive 3D technologies like virtual reality? How much more could we learn about the universe? What other impossible feats could we achieve together? I'd like to thank our sponsors from NASA Jet Propulsion Laboratory, Nat, Marika, and Victor. I'd also like to thank our cohort and all of our instructors, and of course all the researchers and experts who helped us along the way, and last but not least, our family and friends for all their love and support. Thank you very much, everyone. We'll open it up to questions.